DraftScience video off the day. Alright, I still have his other videos, and I haven't played them, and I can save copies of them, so I'll wait for some other time, I guess. So anyway, he's being polite. So, okay, I'll be polite. Let's try to be scientific. Let's have a disposition, temperament. Let's use some professional temperament in terms of arguing points. So all right. So he's 5 minutes into this video. He has a chart here that I hope will come up with something. I can't really make much out of it just because it's saying things that don't mean anything, like atomic nature, mass, Lesage, gravity, which I really don't want to argue because it's fundamentally, that was always argued just because they couldn't quantize it. They couldn't turn it into something purely kinetic that didn't involve a transfer of energy. So when you really understand that we're made out of energy, then you can kind of understand that energy can't transfer energy with energy. There's no extra energy. It's all energy. And it can't do anything. It can't transfer anything to itself. And so what's really being... So anyway, so we're sort of getting to that. So see, my argument is this idea of understanding it as particles is the fundamental first step, is to do the quantum thing. First figure out that the field is a quantum, a checkerboard, let's say, and has checkers on it. Now, the fundamental absolute truth might be that there are no checkers. Okay, alright, now that sounds insane, but I just mean that there's nothing, the identity part of this game, it's like the ball bearings. You could have the ball bearings and you can move the ball bearings, right? Just have a whole big field of ball bearings. Or then you could realize that if you mark the ball bearings and you say this one's polarized in dimension 1, this one's polarized in dimension 2, this one's polarized in dimension 3. And so you would just basically give them a distinctive mark. And then kind of realize that they're just sort of jostling, banging into each other. So they don't really move anywhere. But every time they bang into each other, they transfer their color, their polarization. So if they were like red, blue, and green, let's say, you could understand that when they bang into each other, the blue one becomes green, the green one becomes blue. So now we're into like a Tetris thing or something, some kind of, so it's not a moving model anymore, because the only thing moving is identity. And I've sort of hinted at that's the ultimate truth here, is that the only thing changes is identity. Say if I shoot a laser, the absolute truth might be is that there was already gravitons going the way the laser's going. That beam already exists in the physical reality, and all you're really doing is marking the gravity as polarized light. Now you're giving it a polarization and a frequency, and now you can identify that hunk of gravity. But that stream of gravity was already moving. All those bits, all the bits that make up that laser beam aren't new bits. They aren't new bits you've introduced into the universe. They're just the same bits that were flowing in the universe already, and now you're marking them. I mean, there's laser beams of gravitons flying through me all the time, in all directions. That's how dense the field of gravitons is. That's why they can move planets, is because these things, there's a ton of this shit. But I'm just saying, for the sake of this argument, where I'm just trying to say, look, the bent space, time dilation shit of Einstein, the relativity crap, is the wrong idea. The wave photony thing is the wrong idea. And the right idea is this idea that this is the field. This is what establishes fields. And so I'm just saying, from my perspective, step one is accepting this idea of the kinetic school of fish analogy, right? What you're saying to me is okay, ultimately I'm going to say the fish are made out of plankton, right? And it's a sea of plankton, really, and the fish are kind of an illusion because they're just a group of plankton themselves. You get what I'm saying? It's like But what needs to be first understood is the school of fish is something that does exist. And so let's deal with the thing that exists. Let's deal with what we can identify. And I'm just saying that I don't need to go all the way into that deep argument that the fish are really plankton and they're in a sea of plankton. That's going too deep for what I want to accomplish now, which is let's understand this quantum bit idea, this idea that this is really the quantum of energy, and that the photon is based on it, that the magneton is based on it, however you want to do this, the electroton and, the charge ton, and that all of this is made out of this. That's the more important thing for this step 1. And then you do step 2, and you do steps 3 and step 4, and then you get deeper and deeper into this idea that what's really identifying a graviton isn't so much its momentum as it is its orientation, its polarization, and its relationship to other gravitons by frequency. And that's where I was trying to just get to the idea that light is polarization at a frequency, and magnetism is polarization by mass. And that's why it has so much strength. It's taking all the gravitons and polarizing them. Alright, let's see if this is a way to... So it's not so much... So the ball bearings are a little more complicated than just ball bearings, because you can identify them as this polarization. And this polarization is the thing really being collected in the field. It's not so much real movement. It's really the collection of the blues like blue and the greens like green. And it's the segregation, the filtering by polarization that's really creating the energy imbalances we see. Alright, that's a kind of a long answer. The long way of saying I don't want to take this argument as deep as you want me to justify at this point. So I'm not saying you're not entitled to it. I'm just saying I don't think it's necessary for me to make this argument that gravity is an actual force, a thing. It's being caused by something. It's not being caused by bending any space thing or any of that nonsense. It's a real force. And I think that's the first step, is to get that understandable before I explain that the real force isn't really, that the rain isn't really raining. The rain is just vibrating, so you end up back at waves again. And you know how much I do not want to go back to any notion of waves. But it's the idea is that the movement is really a movement of organization, frequency, and polarization. So it's a movement of filters. Is that enough way to say it? Well, anyway, so hopefully that's not all you want to talk about. It's like talking about the origin of orbits. I don't want to get lost in abiogenesis. I want to talk about evolution, if you get what I'm saying. And you're saying, okay, well, I mean, I don't think Einstein was put to any of these standards. He just says, here, space is bent. Look, I can bend it, and it matches the math. Well, I can match the math without having to go this deep. So I'm just saying your expectation that I go deeper, I think is just going to create more confusion than clarity. So I'll play a few seconds of this so you understand what I'm talking about. He's really asking for a depth that I think is just unnecessary at this time in the argument.
Because both principles at face seem to argue a conclusion that however the dice is rolled, however God or the Big Bang or the eternity of it came into being or just is, however that is how it always is. Both arguments seem to point.
Yeah, well, whether or not it's always is doesn't really matter to me. I mean, with the field conditions, how you get to a certain field condition like the present field condition has matter in the universe, it's galaxies are forming, this, and this. Who knows what it would evolve into, right? I mean, black holes could get massively large and then they could blow up and blow up whole sections of the universe as far as we know. We don't know how the universe ages. So let's just presume that it does some cyclical thing or it does some kind of thing. Let's just say that the Big Bang is a reality, that it actually did condense. It was in some, not a singularity, but in some more condensed form, and that it expanded through an explosion, as explosions would be known. And that, like a pipe bomb, it had to have structure to be able to explode. There had to be something that created the pressure. So there had to be some matter in that early condition, some hydrogen or something. And that obviously that matter can't move the speed of light, so it slowed down the explosion, created this gradient, this area of higher pressure where there's a whole bunch of this quanton stuff still bouncing around in different directions. That's what creates the random directionality. So, you know, whether you think of it as the pressure field in a nuclear bomb, and that's where the universe is as we know it, we're in the pressure wave. So we're in the place where you do have stuff happening because there's a whole bunch of stuff trapped in this area that you can't quite get out yet. But it really doesn't matter. You can also just say, yes, it's a randomized field that always existed and always will exist, and I can start from that position too, and just argue that this is what the universe will just keep doing. It'll keep making galaxies, it'll keep destroying galaxies, it'll just keep eating. It'll keep playing by these finite rules that say if a sun gets too massive, it blows up. These are the rules, right? I mean, we see stuff like that happen. We know that the universe has life and death cycles. So, you know, the cosmos. Things are born and then things die as things. And maybe they just do that forever. So I can start from either position. I'm just saying I don't think I need to do this abiogenesis thing. I think we can deal with the periodic tables existing, that orbits are a fact, that quarks and protons and neutrons are all big hunks of, like they're hurricanes, big hunks of stuff swirling about, and that they swirl together. You know, there's complementary swirling and uncomplementary swirling. And that's what's holding matter together is you know, in essence, is having complementary swirling in pressure. So just acknowledge that there's things tending to push them together and that they're going to find a more balanced place, condition. Just as if I put two checkers in the field of ball bearings, the two checkers will find a closeness that's compatible. And like I said, we know that they do become different sizes, that we do, and there's a size issue here. Protons are bigger than quarks, you know, that kind of thing. And that it takes a certain amount of energy to smash them together and create the new mega hurricane. You take two little hurricanes, and if you have enough energy, you can smash them together. So I don't want to get into those kind of details, though. I'm just saying, for this big picture, I mean, this, you know, I'm just saying that the real thing we're doing is we're changing this diagram of the model. So I'm just saying, to get into this graininess of the model at this point in the conversation, I just don't see that to be to my advantage here. I don't think. I think that's just going to make it sound confusing. Alright, that's enough. I'll play it for a while and then I'll be back. Alright, so we're 10 minutes in. So he says his principal objection is some sort of lack of intermediate steps. Again, he wants some explanation for why different materials have different properties, and so he wants a diagram. I think that, yeah, I don't think he's asking that from physics as it exists now. So I don't think he's asking physicists to explain now how exactly hydrogen becomes helium, and how exactly the helium is different from the hydrogen, and how helium becomes copper, and how this becomes carbon, and how all these different molecules have different properties based on just adding some more atomic weight. Why should adding a little bit of atomic weight make the molecule behave completely differently, and one floats, and one's lighter than air, and one's heavier than air, and one's this, and one's that, and one's all this stuff, and one's radioactive, and how, and no, they haven't explained any of that stuff. And so he's expecting me to give you to provide all of this explanation. what I'm saying is orbits can be orbiting a lot of different ways. I can take two bicycle wheels, and they can be next to each other, spinning in opposite directions, or they could be next to each other, spinning clockwise and counterclockwise. They'll end up with the same flow, right? So they'll be compatible. They can ride on each other, so to speak, and they'll have stuff can go right in between them. You can make a ball shooter that way, right? You have two wheels spinning opposite directions, and then you shove a ball in and it shoots the ball really fast away. And so clearly that could be a thing that generates an extra spin, a residual eddies and all this kind of stuff. So I can come up with mechanisms, and I can say, okay, can you combine 5 of those wheels? You combine 17 of those wheels in a radius, okay? And I'm saying that's going to be an entity, a thing, a compound. A way of arranging carbon, let's say. Now we know that carbon arranged one way is a diamond, carbon arranged another way is graphite. Very different substances, very different properties. So all I'm saying is clearly there's lots of properties you can make out of these different ways of things being arranged in terms of how they're associated with each other, their compatibility, their structure. And I'm saying that a key element to that is this idea of polarization, the idea of them spinning in the same plane. I'm kind of arguing that atoms are made out of galactic style orbits, flat orbits. That they're not round things, they're flat things. And that those flat things can be arranged in a lot of different ways based on their size. Also, how big the pieces that you're making this thing out of. So in a way you could have a thing spinning in the center, then you could have little electrons spinning in an opposite direction, in a field around that. And then that creates another field where something else could exist as a big giant spin around that. So you could almost argue that theoretically it's possible that a proton is a hurricane in the middle, and that the electrons are little storms, and that the neutron is actually another field of stuff spinning. And then you could argue that this is the charge differences between these things, why they affect each other, and we call that charge. But you could also see how if you break these things apart, if you find some way to rip them from each other, how they would still be maintained, but they're in an unnatural state and they might degrade. They might need structure to be able to be maintained in the shape they are. They'll change their shape if you take them out of their field environment. Kind of like how tornadoes fall apart as soon as they hit a high pressure. They die. So I'm just saying this is, so as soon as you change the field dynamics, you change the structure. But I'm just saying, you want me to give you a granular view of this entire field thing, which I think is like asking Darwin to do abiogenesis. I don't think what Darwin needed to do was talk about evolution, not the evolution of the chemistry, the evolution of, well, let's already figure on the existence of chemistry, okay? You're asking me to do something I think that's just way beyond. I mean, yeah, I could sit here for 2 years and then maybe I can draw these pictures for you. I think I've already started to draw some of these pictures. So, you're playing this game like it can't be done and it's unimaginable. But I think I've started with these pictures. All right, so you can say that, oh yeah, this isn't enough. I got to give you more. Okay, I mean, granted, I don't know what to say to you. Okay, again, I'm trying to get the theory of evolution accepted versus a God theory where space is bent. And there's this idiotic relativistic notion that any velocity is the same as any other velocity, and that we can all go, we can travel the speed of light, and it's inconsequential. Yeah, I'm countering that. So I just don't. If you're going to hang on the fact that you want me to explain again the abiogenesis, the evolution from a simple little orbit to a bunch of orbits getting connected together, or whether they all need to have the same polarization or maybe a different polarization, just might be what dimension they're actually spinning in. When you do this in 3 dimensions, it gets awful complicated, but that might be all polarization is. Polarization just might be what dimension you're spinning in. This one, or this one, Where's the other one? Where did the other one go? This one. This one. Well, whatever the other one is. Yeah, and that's all polarization might be. But, I'm just saying at this stage, sorry. Yeah, I can't do abiogenesis at this moment. I think I have bigger fish, so to speak, to swim here. Anyway. So let's see what else he complains about. I'm just saying, if you're going to hang on that, then yeah, go ahead, hang the whole theory. I'm just saying, I don't think you demanded that from any of the previous scientific theories. I don't think you've asked anybody to explain dark matter or to explain, again, bent space. Where? Show me some bent space. Have you really asked to see a beam of light bend? No, I don't think you've done any of that. You've just taken it on, okay, they did an experiment in 1919. And they never repeated it. So, yeah, that's good enough, right? Isn't that the scientific way? Do an experiment and never repeat it? Isn't that how you're supposed to do it? Never repeat the experiment? Yeah, I'm sure. Yeah. So, come on. Yeah, it really is cutting this into minutia that I really don't see any purpose in. Look, my point is that magnetism, as I'm arguing, okay, we know that there's different compounds have different structure. There's plastic, there's paper, there's all kinds of different compounds. And the argument is that magnets are made out of a compound, and the property of that compound is that it's sensitive to polarization. Now, I don't think that's a bold statement to make. Okay, that it's like a polarized film, like polarized glasses. It does something to the stuff that goes through it. And it's sensitive to this thing called polarization. So it absorbs arrows that are polarized in a certain direction. It converts arrows that are polarized in certain directions into its direction, and it's invisible to some arrows of a certain polarization. Now, it's a simple principle based on the fact that we know what chemistry already exists. I'm just saying that for you to say that I need to go all the way back to the very origin of matter to explain how the atoms become sensitive to polarization, or how they become capable of polarizing the field as it moves through them, I think it's just asking for way too much, and it's more than anyone's ever asked of Einstein or any of these other people with their theories. No theoretical physicist has ever had to come up with that minutia. So I say bullshit. With all their accelerators and everything else, you've never asked for that kind of granularity. And so I'm saying that I'm going to be able to provide it, but it's going to take a long time for Darwin to get to the abiogenesis chemistry. Yeah, it's going to take a little bit of time and work. So I think, I won't say fuck you, but I'm just saying this sounds like bullshit. All right. So the field thing is on now. So he's dealing with this basic principle, right? Now, if I flipped coins, you could understand that if I flipped coins, I said you go forward every time you get a head, and you go backwards every time you get a tail. You could sort of understand that after you flipped a few hundred times, you have gone nowhere. Right? You have just gained no ground. You're not further forward, and you're not further behind. You're nowhere. Basically, you might be a step different. You're step 2 off. That's it, percentage-wise. The amount of distance you can be off of that center point. The more times you flip, the less you're going to be off that center point. If you flip a zillion times, you're going to be so close to just one spot, and you're never going to get anywhere off of that one spot. The more times you flip. So he's arguing that and saying that he wants, what he's missing here is that, look, my point is that you're going back and forth. The point is that the fundamental nature of an orbit is you go up and you go down. You go left and you go right. That's the nature of it. It's conservative. It has that principle built into it. And so that's what I'm not arguing about just jostling. I'm arguing about the nature of an orbit. And orbits are what are creating this structure. So you have to understand that this is about an orbit. Even if it's not a round orbit, it's about the idea of that box. Because that box becomes gravitationally significant. It makes something that now can absorb directional information and create shadows that force other things to shadow back. So the way I would analogize this to you is that let's just go with the fundamental, the basic premises. Okay, I'm not going to explain why something exists. I think this is just bullshit to say I have to explain where the universe came from and where its initial condition came from and all this kind of crap. No, I'm saying is the premise for this theory, which I don't think is asking too much, is that there's a perfectly random field. It doesn't really have to be perfectly random. To tell you the truth is we wouldn't know if it wasn't. But the point is that theoretically there's as much arrows going in all the directions. So let's say I am in this field of arrows, and I'm left arrow. Okay. Now the argument would be is that let's say this is the field over here. Okay. So this is me, and I'll just pretend I'm separate from the field. Now the field, since I own this forward arrow, the field is +1, okay, the opposite direction arrow. So you could understand that now the field obviously has an extra arrow to compensate for the arrow I'm using. So I'm using this arrow, and now it has this extra arrow. So let's say an arrow bangs into me. So now I have this identity arrow. Well, this one went back into the field, right? So the field got this arrow, and now these two are balanced again, right? 1 + 1, so these two x'd out. The field is now neutral on arrows going this way. But now I have this arrow, so now the field is plus a negative arrow, right? You can understand that, right? So now if I create orbitals, and they're spinning in a direction, all right, and they have more spin in one direction than they have in the other, so they have more arrows going one way than the other, so they collect 10 of these arrows. Now the field is -10 of those arrows, -10 of them. So now the field is getting more and more, and it's this local field, right? So let's understand that I think you understand the granularity here. So it's so granular, there's such a heavy density. But the fact would be is that you would have yourself, you would have your local area where stuff can, you go forward, you go back, and it ends up being neutral. So this would be like 100 coin flips, okay, of thickness. And then 100 more coin flips of thickness. And 100 more coin flips of thickness. And so the fields are thicker and thicker. And so when a change happens, when I'm absorbing 10 of these arrows, I have 10 extra arrows, and this local field is -10, okay, of those arrows. It's just this local field. And maybe some of that will leak into this field, and this one will end up being 3 arrows minus. And maybe some of that will leak into this one, and it'll be 2 arrows minus. But the idea is you can see that any disproportions will start off in the local field, and it's going to take a while for any imbalance to leak into the bigger field. And so that's one of the properties, characteristics of this field dynamic. And then when fields meet each other, it's like something's 500 coin toss field could intersect into somebody else's 100 coin field. Fields can go, fields of different density could reach into different fields of different density in terms of how far they are from their local whatever this arrangement. But again, the evolution of this imbalance, how this imbalance was created, again, is happening in nuclear stars. It's happening under extreme pressure. It's happening in big bangs. There's lots of ways I can explain how these orbits get thick with imbalance, and thick with what might be called energy of momentum, velocity. And velocity is the extra arrow thing. As soon as something has a velocity, it's acquiring extra arrows. It's got imbalance in it. Okay, it's taken from the field arrows going in the direction of its velocity, and the field is minus those arrows. And so there's an imbalance in the field. The field is doing the other direction more. And so now the coin tosses in that field are going to be prejudiced towards those arrows of opposite. The equal but opposite is going to be in the field. Yeah, so I think, again, going into that granularity to make the simple argument that magnetic materials have properties, and those properties are they're sensitive to polarization, I don't think is a bold statement. I don't think it's a bold statement for me to argue that photons are bits, pieces of this field, that have polarization and frequency. And I think these are fundamentally important facts, and I think they're more important to be understood first before you get into the complexity of this probabilistic field dynamic that has to do with the generation of spin and how these spinning things absorb arrows. It's like me saying, look, the Earth gets pushed into the sun. It doesn't really get pushed into the sun, right? I mean, I'm using this metaphor and saying, well, look, you just think of it as heavy, dense field. It creates a pressure. A bunch of arrows are coming in. It pushes the things together. But it doesn't really push them together. As I've pointed out, the Earth has to absorb the energy. And it's when you absorb it and create acceleration, that's when you're casting a shadow. You don't cast a shadow if you're not first absorbing through gaining acceleration. So if you're not accelerating, you can't be consuming arrows, and therefore you're not casting a shadow, and then the thing that you're opposing couldn't possibly feel any gravity because you didn't cast a shadow. You only cast the shadow when you absorb the light, if you understand what I'm saying. So say we were transparent to sunlight, and the only time you could block, create a shadow, was when you polarized, and now you became opaque to the sun and you absorbed it. So the sunlight went inside of you and you gained potential energy. You became energized like a battery because you ate the photons that the sun was producing, and that's how you made a shadow. You see, it has to be a transfer, so you can sort of understand. It's like those glasses that change color. You have to absorb, the quanta before you can cast the shadow. All right. But I'm just saying, for the sake of the argument, I think the fish analogy and the dancing analogies, these are important analogies. And then we get back to the Feynman argument, about this stuff being friction in space, and why there's no friction to this dynamic. Why? Because most of your matter is not going to be doing the colliding with stuff. Only a tiny % of your imbalance is those 10 extra arrows. Those 10 extra arrows mean you're going 10 miles an hour. They add up to real velocity, and even though it's a tiny amount. And so you're really not enduring any more interactions in any kind of significant way, because most of your matter's still orbiting. It's not going that way extra. So it would almost be making the argument that even when you're standing still, that you would somehow be burning energy. If you're not burning energy standing still, then you can't possibly burn energy by having a velocity in empty space. That would be the simplest argument. If it's not happening when you're still, then it's not going to be happening when you're moving, because the two conditions are fundamentally identical. As far as the space is concerned, you're not going to hit more things by moving through the field. If I jump from the spot I'm in, and I actually go to another spot in the field, and I go to another spot in the field, it's still exactly the same field. I haven't changed this field. So you have to think of it almost like a clock speed, that from every position you get to, you're not in a position where you're encountering more field. It's always the same amount of field, because the field is moving the speed of light. And so are you. Alright, so that's probably enough of that. I think that's all to get to for this part. But yeah, I mean, I'm just saying he's getting too lost in the abiogenesis of this argument. I'm arguing evolution. I don't think I need to do abiogenesis to do biological evolution.
Mass. Almost. Yeah, maybe. That might account for something, where there's literally a space in some manner between all the particles. I don't know. I don't think this works, but...
Yeah, well, see, I'm not saying there is a space. What I'm saying is that there's an arrangement of, again, go with the word polarization. So the atom could have a whole bunch of crap all around it, and even inside of it, but it's not polarized crap. So it's only the polarized bits that are identified as the parts that matter here, and they're the ones that create this thing, frequency. The distance between them becomes important. So it's just distance between polarized bits of same polarization. So that's where this gets interesting. It's like I could have a light beam that's full of extra gravitons, but all it really matters is the frequency, the polarization of the ones at the right frequency. So as long as the ones at the right frequency have the same polarization, they'll be identified as light. But they won't be identified as light if they don't have the same polarization.
What I'm going to say is that when no matter how dense they are, by virtue of their size, we have vastly more distance to travel in collision as compared to their size.
Yeah, well, again, the distance thing on that scale doesn't matter. That's why I've sort of made the argument that let's just say time happens through interaction. So it doesn't matter about distance. Distance is traveled instantaneously, and let's just say interactions take 1/1000th of a second. So there's your creation of time. I'm just saying you can account for time by just doing it based on interaction. You can just say traveling the distance is for free. That did take no time at all to get from A to B, but there's so much A and B is the point, right? So light travels at a certain speed through space because space has a certain density of these quanta in it, and so there's a certain consistency to the number of interactions. And then through some matter, there's a more density in terms of they're more polarized, and so you're more likely to have interactions with the ones that are polarized. Or the ones that are polarized, the interactions take 1/1000th of a second extra. So I'm just saying time can be accounted for in any place here, and time wipes out distance. So I just don't see the point in getting lost in arguments about distance. I don't care one way or the other. I mean, I'm just saying I think the distance is all standard, and I think the spacing is probably pretty close to standardized. But I'm just saying it really doesn't matter whether there's variation in distance if that variation doesn't cause anything consequential. And I don't think there's much evidence that that distance is very consequential, except for in a key component of frequency, which is very important to orbit dynamics. So obviously the orbits have a clock cycle, and it's important in terms of where something encounters two things, whether or not it can be maintained in the orbit. So if two meteors are flying into a galaxy, whether they're going to be kept has something to do with where they arrange themselves on those fins of the galaxy in terms of gravity. And so they have to hit at the right time to both be kept as new possessions of the galaxy. But again, this is a granularity that like I said, I don't mind you being curious or wanting the answers, but I don't think this really has anything to do with me saying it's evolution, not the Jehovah of bent space and relativity. Yeah, well, now he's doing this. He calls this a problem. Okay, well, whatever. Like there's no solution to it or something, or it's a big. No, I haven't spent any time worrying about this because I just don't think it's relevant to any of this. Okay, so look, he's making these objections. We have a current theory where they've explained gravity by essentially using gravity as the model. So the model uses gravity to explain gravity. And if you three-dimensionalize the model, it doesn't explain anything. It has an endless convergence. So stuff just keeps, like strings are getting pulled in by anything that's gravitational. And there's an endless stream that everything's flying on or floating on, and it gets pulled in by the stream, this endless convergence. Have you ever asked to have that explained to you? Where's the energy coming from? How does the sun keep pulling and pulling this stream of convergence in? It pulls the earth in. It gets pulled in by this pulling. Have you asked for any explanation? No. I've given you an explanation for inertia and velocity and how we possess those things. It actually changes your matter, and that's why you have velocity, is because your matter is actually now full of a changed condition. I've explained magnetism and explained and given you a force, a reason why the things push in, or the reason why they repel, an actual force. They haven't even given you bent space to explain magnetism. They haven't given you bent space-time. They haven't given you anything at all. And you're doing this? I'm sorry. Yeah, okay, fine. I'm just saying, fine. All right? But I'm arguing evolution, not abiogenesis. And if you really think you can't believe in evolution, right? So somebody could show you the Grand Canyon. They could show you dinosaur bones. They could even show you the human genome. And it really just doesn't matter until they give you abiogenesis. Is that your theory, your point? So now he's saying, look, there's this distance difference. So even though, yes, the odds of probability are that the left arrow thing is going to get all balanced out, the distance thing won't get all balanced out. I mean, I don't want to point out the obvious to you, but the distance thing is just like the flipping of the coin thing. It's the same thing. It's just rolling a dice. And for every time you go 10 feet this way, you go 10 feet the other way. So it'll end up the same thing. Varying the distance is just another variable that will be dictated by randomness. There won't. Are you saying there's something less than randomness that's going to decide how far apart things are? That's going to be just as much of a random field. So if you've used up the 10 feet that way, there's probably a 10 foot going that way that is not used up yet. I just don't see how it means anything. Again, I don't even care about eccentric orbits. I'm not even saying that things have to orbit in perfect circles or any of that stuff. So whether they orbit in triangles, it just doesn't matter. The point is they go up, they go over, they go down, they go over. That's all that matters. And functionally, it only matters in the sense that there's a certain amount of movement in each direction. So again, I just don't see any point in it. And as I've stated in earlier videos, I just don't think this variable has any meaning. I think the interaction is what takes time. But it just doesn't, I really can't see getting lost in that minutia of trying to figure out whether time happens when you're actually traveling from point A to point B, or whether time happens when you have the interaction. This is what the whole thing should hang on? Accepting this theory or not accepting it should hang on whether or not we've figured out whether time happens when you're moving or whether time happens when you're interacting. I'm sorry not to take it seriously, but frankly, I can't possibly see how this is what everything should hang on. I'm showing you the hip bones of a fucking porpoise. And I'm saying, you know, do I really have to explain that there was legs there? Do I? All right, anyway. I'm just saying, if this is your kind of, if this is the level of objection, then I guess you don't believe in anything, right? I mean, if this is going to stop you from understanding something conceptually being valid or invalid. And again, I'm just saying my theory is not only unified, they're not only based on everything having these three simple statements. I mean, it explains it. It actually explains why things are the way they are, why it happens, where the energy comes from. And that's something I wanted to point out, was just this idea that, so this is another one of the things that'll be one of the proofs here, you know, the predictions. Because my theory obviously says there's a limit to gravity, or a limit to magnetism. Like that you couldn't build the most huge magnet in the universe and then build one a little bit bigger and it'd be a little stronger. There's a point where you use up all the energy gravity has. All the field energy is blocked and you have absolutely zero, okay, energy on the other side. So you've consumed all of it. There is something that can do that. And so it's like there's a limit to the size of a black hole. You can't make an endlessly gravitationally bigger black hole. You get to a certain size and you can make it twice as big and it'll still have the same amount of gravity. You just can't suck any more out of the field. So that's one of the predictions of my theory that's not in the current theory, because they can bend space-time forever. They can just make their well deeper and deeper and deeper and deeper and deeper, and that's why they do all this singularity crap and all the rest of it, is because there's no end to how much energy they can make. They can just make the hole deeper and make more energy. Where my theory says the field has a certain density, and once you've sucked all the energy out of that density, there's no more to suck. So that's one of my predictions. Alright, anyway. I mean, it's getting a little annoying, because this is not, like I said, you're just not the kind of person I need to talk to, because obviously I can't, you want every single elemental impact that ever took place in the universe diagrammed, and I can't do that for you. Like I said, we can't even do that for evolution. We don't have a diagram of abiogenesis, and we may never. And I just don't see that as an impediment to understanding that we evolved. So, whatever. Alright, so now he's conceded the checker argument about the checkers going together, so at least, maybe he should do something to qualify his buffoonery video. But anyway, regardless, I'll watch it in the future and piss me off, and I'll, remember that I hate your guts. So go ahead, leave it the way it is. But anyway, so now he's going to get into Lesage gravity and lensing. Lensing is where he's supposed to be going. Now, if he gets on lensing, I think he's going to fail, because clearly the evidence of lensing is absolute crap. We have the 1919 experiment that we don't get to analyze at all. As an observer, we don't get to see the experiment in any real way at all. And we have a bunch of deep cosmic lensing at ranges of 5 billion light years away in loosely configured galaxies of vague notion of gravities that are made out of dark matter. I'm just saying, that's really crap as evidence. So if you want to say that I'm somehow wrong to say I think there's a hole there, and again, this isn't a hugely significant detail to me, the fact that light can't be bent. I mean, this is not critical to my theory. I'm just saying that their theory needs it, not mine. Their bent space notions don't really work unless they can bend light too, right? But I'm just saying their bent space thing doesn't work anyway, because it's a lame contrivance. It doesn't explain why anything goes down the bend. Magic. Because there shouldn't be any gravity in the model, right? The model is supposed to explain gravity. It's not supposed to use gravity. Right? I mean, is that right or wrong? I mean, plainly, is this an appropriate question to ask? If I make a model and I'm saying the model is explaining the force, and yet I use the force to make the model work, isn't that like saying I have an electricity making machine and I have it plugged into a battery? Is there a difference? Okay, so let's see what he's going to say here. The inverse square law. So he just mentioned the inverse. Your theory accounts for it. Says the inverse. Look, Feynman said that. Feynman said that Lesage gravity would satisfy the inverse square rule. So it's not just me saying it. Feynman said it.
Thus, some galaxy
I mean, galaxies are a wrong thing to use as an example, because as I've pointed out with galaxies, they're not hard, okay? They're not real matter. They're not solid matter. There's too much empty space in a galaxy for you to use it as a focal point of an argument for Lesage gravity. Only in this sense, that you have to understand that just like there's no Earth opposite Earth, okay, on the other side of the sun, there's no Earth over there. Galaxies are essentially like having the current solar system and having a duplicate planet on the opposite side. And you could understand that that would really change the orbital dynamics. And so I'm just saying you have to kind of understand that. Lessage gravity still works. I'm just saying it's not going to work with you saying the sun is the center of the gravity, because in a galaxy, most of the gravity, in my opinion, is probably being created by these arms. And that's why they're always centric. These spokes are where the gravity is coming from. That's where the mass is.
Some galaxy will have, by the inverse square law, some effect out here. Alright? Some force by your...
Right, okay, so I don't know why he's doing this with a galaxy. Like I said, it's just a sloppy way to do it. So you can combine all of the mass in a galaxy, but again, so it's going to be even lighter than the sun. So just as the sun, even though you could fit 1,000 Earths inside of the sun, or maybe more than that, right, a huge number, the sun's gravity is only 7 times stronger than the surface of Earth's gravity. Only 7 times, because the Earth is heavy matter, high atomic number matter, and the sun is low atomic number matter. Now you can understand that a galaxy is even lighter, okay, than a sun, because of all the non-matter, okay, that it's full of. And it's a disk. It's not a sphere. So you can only do your inverse square this way. You can't do it this way because it's not a sphere. It has no spherical gravity. Well, it has some. But I mean, obviously the strength of its gravity is along its plane that it's spiraling on. So only this way will the inverse square rule be obeyed. It will not be obeyed this way.
All ideas by Lesage theory. If it has an effect, and a diminishing effect nonetheless, what this means is that the object...
Look, this is a really good argument for polarization. Just because this sort of explains it, right? That you could sort of understand that, let's say there was another galaxy that was orbiting this way. So this one's spinning this way, and this one's spinning in the opposite dimension, okay? Now you could sort of understand that most of the gravity from this one is not going to be affecting this one on this plane. It'll only be a very narrow part of the gravity, and equally for this one, the strongest gravity is on this plane, and it'll only be hitting little linear spots on the galaxy spinning in the opposite direction. So this is where polarization becomes important, because if they were on the same plane, then their gravities would be much stronger towards each other than if they're on opposite planes. So things spinning on flat things, Lesage gravity is going to say that you're only going to have diminished, you know, the weaker potential, right? So we're talking about the weaker pressure. So understand that this will have weaker pressure in a flat plane that comes out. Only in a flat plane. There won't be weaker pressure in this way. There will only be weaker pressure in this flat plane. And this one will have the same thing. You'll only have weaker pressure in this one plane, and everywhere else it'll be the same old gravity pressure. So again, you know, they do this with this stupid gravity wave thing they all keep talking about. Gravity waves will not be evidence of some new energy, some extra energy. Gravity waves are created by it's like the two-slit experiment. It's the empty space that's significant. It's the empty. Gravity waves are being caused by an absence of gravity. Gravity being absorbed. The energy of gravity being absorbed. So gravity waves will not be a demonstration of energy. It's a lack of energy. Oh, I mean, it's just amazing they can't get that right.
For this area of the lens, and it isn't an even lens such as this with with one specific focal point. What you have actually is, because of the inverse square law, you have an effective body of material.
Well, again, so if you're going to make a lens out of a galaxy, this is where it's going to get tricky, right? Because the gravity is planar. Okay, so frankly, you'd have to have the galaxy on end to really get the effect of the gravity as the light went through it. So, you know, like I said, the very idea of using galaxies for lensing, Einstein never validated that as a concept, ever. So you can make this argument, but relativity, the lensing predicted by Einstein had nothing to do with using galaxies as lenses, because Einstein would, I think, quite correctly point out, galaxies are fluffier than suns are, a lot fluffier, and their gravity is not going to be sufficiently strong at any distance. There'll be no center. So go to the gravitational lensing's website, and they'll talk about these different kinds of gravity, maximum and minimum. You can only have maximum gravitational lensing when you have an actual lens where you have a center that's the gravity is most intense in the center, and it gets weaker as it goes out. And clearly you couldn't lens out here. Out here is the weak gravity of the galaxy. You can't create a lens out here. So it's just bogus. Einstein was clear. The speed of light requires light is moving so fast that to bend light, you need to have intense gravity, not weak gravity. Intense. You can't lens where the Earth is, okay, by the sun, because that gravity is only 0.006 meters per second. It's pitiful gravity. And you're not going to bend light out there. You have to bend the light where the gravity is 70 meters per second. And that's on the surface of the sun. And frankly, they can't even do it there. Gravitational lensing is bogus.
With a varying refractive index. So to simplify it,
well, I'm just saying, you haven't simplified it, you have destroyed it conceptually. This doesn't happen this way. You do not make lenses of this huge size and all this stuff. This gravity out here is 0.0006. This gravity might be 0.004. There's no way you can lens with weak gravity. Weak gravity means the lens is not fat. Okay, so it's like if you're using Einstein's thing, the stronger the gravity, the fatter part of the lens. There's no fat part of this lens out here. No fatness at all. There's no lens.
Consider very close as one lens of one refractive index, and very far away as
the image is gone here. Shit.
Another.
I don't know why. My computer really isn't this lame. I don't know why it does this, but halfway through the video, I don't know whether this is a Google thing or what, but it just stalls, and I still hear the audio but no video. It's just really annoying. Really annoying. It's a recent development.
With one specific focal point, what you have actually is, because of the inverse square law, you have an effective body of material with a varying refractive index.
Well, again, so again, look how he's drawing this varying refractive index. There's no way you have any refractive index way out here. There's no way. You can't make lenses out of weak gravity. Can't be done. So I'm just calling bullshit. We're talking about bending fucking light. This is not 0.000 meters per second gravity. Does not bend light.
So to simplify it,
no gravity bends light, but the point is you really can't do it with that weak gravity.
Consider very close as one lens of one refractive index, and very far away as
Look, in theory, for this lens to have any effect anyway, understand that the light, if the light was coming this way, it wouldn't even matter if this was strong gravity going in this plane, because the light would spend so little time in it. Can you see how little time it would spend in the gravity? It would be through the gravity instantaneously. You can sort of understand that even in our solar system, that let's say you were a meteor and you were coming down from the top of our flat solar system, like, you know, in between, you know, Jupiter and Saturn or something. And the two planets were semi-aligned even. You could sort of understand that their influence would last very brief amount of time if you came down from the top. But if you came in from the side, you'd be affected by them for a much longer time. So you could lens theoretically and this line, because the photons have to go through the strongest gravity of the galaxy, right? I mean, the strong gravity is on this plane. And so that plane has the gravity. See, they don't have any, they think, by their theory, this well creates gravity everywhere, because they can make unlimited energy. But in the real universe, no, gravity doesn't work that way. It's a shadow. You have to cast the shadow. These things can only cast shadows this way. They cannot cast shadows up here, you know, of any significance. So the light would, for this lens to even have a lens, for this galaxy to lens, it would have to be, the light would have to go through the thick part of the gravity. That means it has to go through the same plane as the frickin' galaxy. It can't go from the top of the galaxy, because it would go, can you understand? It would go through the gravity in 10 seconds. It would be all the way through all the gravity. So it wouldn't have enough time for the gravity to affect it. Time is important in these equations. That's why orbits take time. That's why the planets have to move slower in the weaker gravity, because they need more time for the gravity to work on them, so to speak, to keep them in the orbit. And there's no time factor here. So you have to understand that this gravity is very different for a galaxy than a round planet. So if you're going to do this, you should have used the sun. Let's do suns first, and then you can explain to me how galaxies lens. But you're not doing it with this argument. I mean, sorry, this isn't good enough physics.
Another refractive index. Thus, the objects for someone located here, which appear as an image in a focus, reveal objects here.
Okay, so again, this is the lens he drew. So he drew this big giant lens as if there's heavy enough gravity way out here to create this lens, and he's drawing it in a sense, like I said, on top of this galaxy. So most of these lensing images you see, yes, the galaxy is facing you, which is troublesome because the thing wouldn't spend enough time in the galaxy. The lens, if this galaxy has a strong lens, it's right on the same plane as all the stars, and then you can't see in the lens anyway because there's too many stars in the way. So isn't that the irony? You can't use a galaxy as a lens where its strong gravity is, because it's going to block your vision with all the suns in the way. But if you use it this way, where you can see, the problem is it doesn't have enough gravity. It goes through my hand so quickly. You get it? Come on, you got to be able to get this, people. I mean, if I go through the top of a frisbee, I'm only in the frisbee for this much, right? That's how much plastic I have to go through. If I go through the side of the frisbee, I have to go through a whole bunch of plastic. Can you get that? Well, that's how gravity works.
In focus as an image. But somebody far out will not receive this object as an image, but will receive an object at the focal point.
Well, look, if you look at the Wikipedia page, it'll tell you there usually isn't a focal point. You'll see light. So if there's light anywhere in this range, it'll end up getting hit somewhere, and especially if this is flat to it. I mean, if it's on the right, if the lens is balanced, you'll end up with light on both sides. But yeah, you won't get an image. You won't get a clear picture, but you will get the light regardless of the focal length. Because the light's coming out in a radian from the object. The sun is spreading the light at all the angles. So it's not just doing this angle, it's doing every single one of these angles. I mean, all of those photons are there, and they'll show up if you have sufficient gravity to do any lensing. They'll show up, and it doesn't matter about any focal length. I mean, this image is just not fundamentally is incorrect. The light is coming out of this at all these angles, all of them. Every one.
From a galaxy far, far away. Okay. And yet some people in the middle will not receive any quality image.
Well, again, the quality image is irrelevant. It's not what lensing is about. None of the images are quality. I'm not asking for a quality image. It's possible if you have the perfect focal length and everything, you'll get an image. But the point is you'll get light regardless, and that's just because you haven't filled in all the lines. So you have to fill in all the lines, and so one of those lines will be one that you'll see. Lenses are not opaque. Okay? Lenses don't go opaque in the middle. Okay, the middle's completely blocked out and you just lens on an edge. There's no such theory for that. There's no theory that says you'll have the lens here on the very edge and no lens in the whole middle. That's not, it's a lens, it's a whole thing. But again, see the planareness of it. Galaxies don't lens strong this way. They lens strong this way. So galaxies are a really poor choice to use for lensing because they have directional gravity. They have dimensional gravity. Their gravity is limited to a dimensional plane.
This simplistic model.
It's horribly underdone model. Yes, it's not good enough. Frankly, it's not good enough to be accurate. Focus is irrelevant. I'm just saying, who cares about focus? The point is, there's not enough gravity in this lens. That's the point. Explain where you got enough gravity out here to lens light, to bend light.
And this is the account for the idea of why we don't see a gazillion things behind the sun. All.
Well, again, you can make that excuse. I'm just saying there's so many objects behind the sun. The Milky Way galaxy is viewable from behind the sun at some place on Earth every day. So whether you have to go out to use it from Australia's perspective or some other perspective, and again, the Hubble telescope can go anywhere it wants to theoretically. It can view it from any point. So I'm just saying there's a ton of stars in the Milky Way galaxy. Put the sun in front of the rest of the Milky Way galaxy and just lens one of those stars. I'm just arguing that this sounds all bogus. I'm just saying we have one lensing with using the sun. One. Done in 1919 by a guy who was the horniest advocate of trying to prove Einstein's theory. So a guy aggressively trying to find proof of Einstein's theory happens to be the guy in 1919 that finds it. And I'm supposed to say this is good science. That's enough. We don't need any more. Pyro is completely convinced. That's more than enough evidence from Pyro's position. I'm saying it's not even close. Not even close to proving you bent light. Even if you got lensing around the sun, I'm still going to argue there's a ton of atomic particles around the sun. The fact that you could get lensing in the Earth's atmosphere, would that surprise somebody? It scatters light all the time. Come on. I mean, if we found out the ozone layer, you could lens with a satellite from the Earth, right? So maybe they put an observatory on the moon and use the Earth's ozone layer to lens. Would everybody be surprised that a field full of atomic nuclei would refract light? I don't think I would be surprised. Diffract light.
Yeah, because there are only certain objects which will reveal it to us.
Well, you're saying that, but I'm just saying the Wikipedia page then disagrees with you, so maybe you should argue with them. But theoretically, no, there is no focal length because this object isn't producing just these two rays of light. It's producing every single one in between. Every single one.
And on this scale, it is local star light, not galaxy light, that will form the image for us.
Well, they've never done that as far as I know. They don't lend stars with galaxies. They lend other galaxies billions of light years away. So the only images I've seen is a galaxy that might be 2 or 3 billion light years away, lensing a galaxy that might be 2 or 3, 4 or 5 more billions of light years away. That's all I've seen. But look, it's all shit. So what do you want me to say? You want to defend the shit? Go ahead. But obviously this isn't what's happening anyway, because you haven't said anything about dark matter, because this isn't happening. That's why they invented dark matter. They invented dark matter because they said, look, this doesn't work mathematically. This is nonsense. So we've got to come up with a way to fix it. So, dark matter. Like Huygens was used to fix the one-slit experiment. They needed a way to explain, well, how does this happening? There's a pattern. How did the pattern get there? Well, let's just invent some silly idea that, okay, it's still, photons really are 2 photons. They're always making pairs of photons. That's what photons do.
On the galactic scale, it's galactic scale focal points that come into play.
Well, like I said, they really don't. So, but whatever, go ahead. I mean, you're saying so. I'm just saying the Wikipedia page will tell you there's no focal length. There's no focal limitation.
And I think this explains, this explanation is a direct contrast.
Well, okay. Well, I'm just saying, if this is what you claim, this is, how does it even contrast my theory? Again, you're saying my theory is somehow dependent on this. No, Einstein's theory is dependent on it. I only argue it because this is just more evidence of why Einstein is wrong. I don't need gravitational lensing. It's really irrelevant to my theory. If you want to say that my kinetic theory can't explain it somehow, that somehow I couldn't contrive some excuse why the light does get bent, well, I could contrive one just like they do. I could come up with dark matter, or I could come up with, well, there's a stick. Okay, photons have a little stick sitting out on one side, and if the gravity moves that stick in that direction, and then when the stick is moved in that direction, the photon bends. I can come up with some sort of bullshit. But I'm just saying, my theory doesn't give a fuck about lensing. It doesn't give a fuck about bending photons in super strong gravity. It really isn't relevant to my theory at all. I'm not dependent on it in one way or another. Again, I brought it up because it's evidence of Einstein's limitation, not my limitation.
And I think this is, these ideas have to be accounted for.
Well, you say. Again, what do I have to account for? Your inaccurate description of lensing? I mean, really, your description was wrong. You can't lens way out here until you explain how the gravity is 70 or 80 or 100 meters per second out there. And then you'd have to explain why the stars in the galaxy aren't moving towards the center of the galaxy at the speed of light, because at 70 meters per second, you'll be moving the speed of light in less than like 25 days. So explain, the suns in the galaxy are separated by hundreds of thousands, millions of miles maybe. So they have plenty of time to gain huge accelerations, plenty of distance to travel, so they can get really moving. 28 days is all it would take for them to be going the speed of light, so why aren't those suns moving the speed of light? If they're in 70 meter per second gravity, how come they're not moving the speed of light?
And I don't think they are. As for the 2-slit experiment and the single-slit experiment,
well, this ought to be really good, right? Okay, maybe I'll keep playing it.
what can I say on that?
Well, I'll save this file. We'll move to the next one. I'll play it for a while and see if he says anything decent. So what can I say on that? So he's almost like conceding somehow that somehow they have some evidence. Again, just show me single slit diffraction and explain to me the diffraction part. Explain to me how the photon gets diffracted without the interference pattern, as Piro says. There's no interference. The pattern is not interference. The pattern is a diffraction pattern. So explain to me how you get the diffraction pattern with a single slit. Just explain that. Please. Alright, so he's doing the diffraction, refraction, reflection, deflection, interference pattern. Okay, so this is a real problem, right? Because now he's saying that diffraction is always a pattern, and that the interference pattern is obviously the pattern causer. The interference can only cause a pattern, correct? I mean, what else can cause a pattern? You know, but that whatever. Okay, I don't care. I'm just saying that let's agree on a language. But yeah, I don't care what the language is. I mean, I actually failed physics over this word. I mean, I actually won the appeal and got from an F to a D by pointing out this argument of refraction, and had an argument with the, and actually demonstrated it. But anyway, see, I would call it diffraction is like a reflection, but diffraction is like recognizing that the, see, you could say reflection is a fake notion, like nothing really reflects light. Okay, light is always absorbed by an electron and readmitted at the proper angle. And so diffraction would be when the light goes in, is absorbed by the electron and shot out at the new angle. It's been diffracted. Now that will always come up to be the reflective index, because that's a reflection essentially, because reflections don't really exist. Refraction is when the light goes in and it bends in. It goes into the surface. That's a refraction. So that's how I would have described it, the distinction. They're both caused by surfaces. Diffraction, refraction. It's just one goes in, one goes out. That's the difference. But it doesn't, like I said, I don't care about these definitions. I'm just saying Piro's claiming it's not an interference pattern in the single slit experiment. So let's just say, if you're saying it's diffraction in the single slit experiment, I'm just saying I want to know one way or the other. What's the argument? Either it is an interference pattern or it's not. I don't care whether you call it diffraction or not, or refraction, or any kind of action. I just want to know, are you claiming interference in the single slit experiment? Are you claiming the photon is interfering with itself? Do you really think the Huygens thing makes any fucking sense at all? That the photon goes in, creates a million waves, eliminates most of them because they don't matter, and then decides to interfere with the one it decided to interfere with itself, that's the one that's halfway away, half a wavelength away. So it just happens to interfere with the one that's half a wavelength away, so obviously now you could have the interference pattern because they're now a half wavelength out of phase. Right? Right. And so you think that's bogus. You think that's legitimate science. That's reasonable. That's something everybody should say, yeah, that makes perfectly good sense to me. And that's not happening in the single slit experiment, obviously, because you don't call it the 4-wave interference pattern, right? It's 2 waves, not 4 waves. Right?
To allow it to taint your entire response, should you make one, with personal insults and so on.
Well, I'm not gonna make personal insults. I'm just saying this 2-slit thing. I'm just saying it is so fucking bogus. I've pointed out to you all these bogus elements of this stupid experiment. I pointed out how they claim there's experiments that they never did. Then they did. That they looked at the thing and they checked the thing, and when they were looking, it happened, and when they stopped looking, it didn't. No, all that shit didn't happen. And now I'm pointing out to you a simple explanation for why the central maxima is twice as big in the single slit, is because there's no impediment in the center, and in the double slit there's an impediment in the center, and that's why the central maxima is twice as small in the double slit experiment, and that's the only real difference between the 2 experiments. So I've explained the experiment, no woo necessary, no bullshit about how, well, if I cover one of the slits it's just a straight blob. We all know that if you cover one of the slits, now you have single slit diffraction, and it will not just be a blob. So can we be done with this and say there's just been a lot of distortion and perversion and grotesque misinformation about what is exactly being demonstrated by the 2-slit experiment? Please? By very professional scientists are misleading people into thinking something's happening when it doesn't happen that way? Isn't this the truth? So yeah, I'm pissed off because you people keep claiming I'm the guy who's got the credential problem. No, I'm saying their evidence has real friggin' problems, and you people are all saying, well, it's not that bad. It's catastrophically bad. They're saying they're explaining that photons are full of magnetism and electricity because of this bullshit. It's a pretty fundamental experiment, and if it's made of crap, I shouldn't be ridiculed because I say, well, shit, can't you see how the Emperor's not wearing clothes here, for fuck's sake?
Again, that is maybe provocative, but sometimes it seems hard.
Well, frankly, it's not provocative to me. It's going to be provocative to Pirro, because Pirro's the one claiming that diffraction and interference are different things.
Not to. It seems hard. This is a slight irony. In trying not to be provocative, one can tend to slip into, in overly trying, a degree of...
you people really don't get this, but I don't understand how you can't really tell the difference between when you're being patronizing, arrogant, insulting bastards, and when, you're saying something that might be a little bit, oh, sorry, didn't mean to say you were fat, sorry. There's a huge difference. You people have been leaving comments and saying things diminishing my capacity to make judgments, to understand the science. You make these patronizing, obnoxiously arrogant statements about how wrong I am about something. And that's obnoxious, especially when, again, you haven't proven me wrong about anything, you fucks. Just amazing.
Arrogance and condescension.
That's the key one, condescension. Yeah, that'll get you nowhere with me, okay? Pirro called the photographer guy, right? He said, that photographer dude. And as soon as I heard the word dude, I'm just saying, there it goes, right? Now he's a dude, right? So as soon as you turn somebody into a dude, that's basically saying, I pwned you. As soon as I can call you a dude, I pwned you. I own you. And that's all Pirro was doing there. This guy, right, this idiot, well, he's an idiot, okay, he has a silly theory of whatever, blah, 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 blah. But regardless, fucker's smart, smarter than Pirro. He could probably beat us both at chess, no doubt about it.
And for that part of it, I ask your humble forgiveness. See, there I go again. But that's just trying to,
Yeah, well, whatever. I don't know why you thought that was an egregious thing, but again, I'm not the one clinging to this diffraction word. I'm just saying, give me the explanation for the single slit pattern, and explain to me why it's fundamentally different than the double slit pattern, because it's not fundamentally different. It's only different in the silliest, slightest way.
Keep the flow of the video going. Right. Oh yeah, I said I'd deal with the two-slit experiment. What could I say about that?
Deal with the single slit experiment. That's the one where, if you're going to deal with something, deal with that sucker. Because as that slit gets narrower and narrower, right, the pattern gets wider and wider. But go with a wide slit, as wide as you can, and still get the pattern, and you'll see a ton of bars. Just a ton of bars. Looks just like the double slit, and it's just got a little bit brighter center, and that's it. So do it with a green laser, and look it up. I'm just saying, look, Google search that instead of Wikipedia. Do a Google image search on two slit, and you'll see single slit diffraction patterns, and they're just as solid can be. And again, so it's only a subtle difference between the two patterns. Very subtle.
Right, yeah. The central question about the two-slit experiment is that I understand by your analysis is that you say
have the same problem getting it on the paper.
Phenomena at the edges phenomena here produces a statistical
yes, the closer you are to the surface, the more likely you are to be diffracted. Yes. So that's the statistical relate. There's field lines. The field lines get weaker as they go out by inverse square rules. So yes, the closer you are to the surface, the more you get diffracted. The further you are from the surface, the less you get diffracted. As you bring the two slits together, the fields start to interfere, and so then everything ends up getting diffracted. But yes, surfaces. Surfaces are causing the phenomenon. That's my contention. The photons are traveling straight lines. They're being refracted. If that's correct. Yes, they're being refracted by electrons on these field lines. Yes.
let's say refraction. And because of phenomena at the edges, you get this statistical, probabilistic interaction at the surfaces. That's as I understand your theory.
Right, and the proportions of those, the distance, okay, of that angle, like whether it's 22 degrees or 25 degrees or 32 degrees, whatever degree it will be, is dependent on the frequency of the light, partially. So the frequency of the light will decide how much diffraction will take place for each level jump to. So let's just assume that the electrons have a thickness and they have a certain, they don't like each other, so they have to be distant from each other in these field lines. So if you hit the electron, it'll be at this position. And then if you hit another electron out here, it'll be at this position. And it's those angles, those differences in distance from the surface, create a guaranteed of a different angular pitch. And so the further away you go from those subtly different angles, the wider that difference will appear.
And what I say to this is that this doesn't account for regions where it seems, regularly spaced regions, where no photons can get to.
Well, again, so if I just make field lines, I'm just saying if there's field lines and electrons only line up on those lines, well, here is where there's no diffraction. So this light goes straight through, and so there's no diffraction of light that would have had the right angle because it's the right distance. So only the light that hits here, here, or here will be reflected, and it'll only be reflected at the angle that this electron reflects at. So I'm just saying that obviously this goes straight through and it comes out in the center. It doesn't go out here somewhere. It goes straight through to the center. It's the center, this tiny, tiny slit, the center, way out here in the projection. This doesn't get wider by projection. So anything that doesn't get refracted ends up here in the center, and only the ones that hit electrons get angularly hit, so that accounts for the dead spaces. The things going between the electrons that would have filled that dead space if they had refracted off of an electron don't hit anything, therefore they go straight through, and so there's a dead space. So the dead spaces are basically made out of photons that didn't refract. So they're the ones that are heavily in the center are really the ones that should have been in those spots if they had hit an electron. But they didn't hit an electron because when they came in here, there was no electron to hit, because the electrons are on the field lines.
Yeah, these in wave theory are the cancellation points. Yeah,
Yeah. Again, in the single slit experiment, these exist. So I'm just saying these dead spots exist in the single slit. So just narrow yourself to the single slit and explain to me how you really think this Huygens thing is what's causing it. This arbitrary, made-up mathematical crap where you just say, let's put it in a make-believe impediment in the single slit experiment. That's all it does mathematically. Mathematically, all you do is multiply by a half. You cut the slit in half, create two slits. Tell me I'm wrong. Tell me that's not exactly what they're doing. They take the single slit experiment and they just end up cutting it in half and making it a two slit experiment so they can make it work for diffraction. I mean, for wave interference.
Now, if this is just surface interference, how can these 4 surfaces coordinate with each other
Well, they don't coordinate with each other. Like I said, it's probabilistic. Didn't we just concede that? So it's always going to be a certain alignment, a distance between the we know that electrons don't like each other, right? They're like magnets, and so they're going to line up on these field lines or whatever lines. They're going to have a distance between them. I'm saying it's a standard distance between them, and that's why you have a standard two-slit response. And the only light that's going to be in this reflected pattern are light that actually hits an electron. So it has to hit one to actually end up getting diffracted and being visible in your projection. The projection only magnifies the stuff that got diffracted. The stuff that doesn't get diffracted goes straight through and hits the middle. And that's why the middle is so much brighter. Okay. I mean, I've already made this point over and over, so I guess.
Explain regions of no collisions, register.
Newton's lensing, okay? Just go back to Newton's lenses, right? Newton pointed out that, look, you put monochromatic light through a lens, monochromatic light, you'll end up with Newton's rings. It's exactly the same thing. There's no need to have an interference pattern to come up with Newton's rings.
Of photons on a screen.
I mean, clearly the wavelength of the light is merely, the fact is that the refractive index only works at certain positions, and at other positions there's no reflection. So that's the distinction. Reflection, non-reflection. Reflection, non-reflection. There are some positions reflect, some positions do not reflect. You can do it with Newton's glass. The thickness of the glass is deciding how reflective the glass is. You're saying, how does it coordinate that? Well, it doesn't need to coordinate that. It has to do with the alignment of the molecules at different thicknesses. And when you go thicker and thicker, then all of a sudden you have to add another molecule. And then when you go a little bit thicker, the molecules all bend. And then they bend a little bit more, and then they bend a little bit more, and then they go back to being straight again. Then they bend a little bit more, bend a little bit more, bend a little bit more, and they go back to being straight again. So it changes the refractive index because the angle of the molecules is changing, like a prism. So only certain angles will permit certain angular responses. And other places will end up being transparent or opaque.
And with that,
it's like the polarizing film. If I turn polarizing film, if I turn it this way, I can see through it. And I turn it this way, it gets darker and darker and darker.
well, I will nearly leave it because this is a point of issue, and I'll just raise it straightforwardly without slight intended, as what I understood as an inaccuracy. You're explaining something about the nature of particles or photons, and talking about slits and things. Oh, it was in your analysis, your commentary on the Khan Academy single slit diffraction experiment. You said, even if this is something to the effect of, even if this is true, it's definitely not true for lasers. Now, laser light...
Well, again, that was about the point that the light is not domed. I mean, damn, this is such an obvious point. The original experiment is done with an aperture. Okay, the light is over here, a light bulb. Okay, they shine the light through an aperture. They create domed light. That means the light is more intense here at the focus and less intense at the fringes. Okay, and then that light goes through the two-slit experiment. All right, so that's my point. My point is the experiment is fundamentally different than it was performed, say, 50 years ago. 50 years ago, the light always went through an aperture. When Feynman did his description of it, he had an aperture. The light went through an aperture. It gets domed by the aperture. Okay, so the light coming into the two-slit experiment is obviously much brighter here and less bright at the fringes. All right, I mean, that's a fact. Now, laser beams are going through completely different. Laser beams are flat light. Okay, it's just as intense here as it is here, as it is here, as it is here, here. So that's why I'm pointing out that in the single slit experiment, quite obviously in the single slit experiment, because the light isn't domed anymore and you have equal amounts going through, there's obviously more likelihood of having diffraction at these surfaces because these surfaces are now getting light that's just as bright as the light here. Okay, the light here is just as bright as the light here, and therefore there's more. The pattern is more visible with laser light. That's my point. The point is their argument that it's 8 times brighter at the center isn't even accurate anymore when you use lasers without an aperture. Lasers without an aperture, the central maxima is not 8 times brighter, and the bar pattern is much more visible. That's the truth. That's a fact. All right, it's not really debatable. This is a fact, okay? I'm just saying that's the fact of history.
Photon per photon is exactly the same as non-laser light.
Again, but the distribution is not exactly the same. If I put light through an aperture, there's obviously the center is focused. It's more bright in the center, less bright at the fringes because it's relying on diffraction. Okay, that's just a fact. You dome the light when you put it through an aperture.
The only difference is laser light is the release of them together. So and they say they can do this, is release the particles one at a time.
Again, one at a time if you did it by dome, or one at a time by flat. So a laser beam's coming in a flat wave, an aperture creates a domed wave. Obviously, if you were to randomize the photons one at a time, to imitate domed light, you would have to hit the center more often than you hit these edges. And to imitate, one photon at a time, a laser beam, you would have to hit the entire surface evenly. You'd have to have just as many photons go here as go here, as go here, as go here, as go here, as go here. So the difference would be how many photons go to what area of the experiment. So it's clearly a huge difference.
And presumably, I don't know about photons, but you can imagine it being more realistic with electrons.
No, I can't imagine it being anywhere near realistic with electrons. Okay, electrons, to me, doing the experiment with electrons is already game over. We already know electrons hate each other. Right? And we know that the surface of matter is covered in electrons, okay? I mean, come on, let's get serious. We know that, don't we?
This is half the problem, is understanding.
I mean, the field around every material object is just, there's a field of electrons that are migrating around it, not too, all the time. That's charge, for fuck's sake. And everything has some kind of charge.
When we're talking about experiments which are true and believed by the community about electrons to have been done, and experiments essentially on the same subject, but which have been done with photons.
I'm just saying, you're going to guarantee a diffraction pattern using electrons. There's just no way you could avoid having all those magnetic effects. But the very idea of shooting electrons is just kind of silly, right? Because they really don't travel in straight lines, and it's just a messy business.
But a photon, if we could release a photon, to all intents and purposes, it is a piece of laser light. It is.
No, I'm sorry. You have to understand distribution. So if you release it through an aperture and the aperture creates the domed light, well, then you have a valid argument. But you're not even getting my argument. My argument is when they do this experiment in the past, they didn't do it with laser light. They didn't do it with light that was evenly distributed across the entire two slits. The light was unevenly distributed. Fact. More light in the center, less light on the fringes. Fact.
It's coherent with itself, it's monochromatic, it's going up and down. You know, there is no issue whether it's going up and down at the same time in classical theatre.
Well, whatever. I'm not going to re-argue this, but just, aperture, absence of aperture. Put the laser light through an aperture, then you can tell me it's the same experiment that was done in the past. But if you're not putting the laser light through an aperture, it's not the same experiment.
Waves. There is no issue of...
Well, there's an issue. I'm sorry. You say there's no issue. Again, you're just telling me there's no issue. No, I'm saying there's an issue. I've tried to make it clear. I've used the word dome. I've drawn this picture about 7, 8 times now of the domed light, giving you this idea that it's more intense in the fucking center, and that's what apertures create. I've done this before. I've done it more than 4 times at minimum. Now I've done it more than 5 times at minimum.
Synchronicity, coherence, the word.
Doesn't matter. Yes, all that's very nice. The point is, it's even.
Which is a further question. In your theory, what is the difference between laser light and normal light?
My point isn't what my theory is. My point is they're using exactly the same math for light that's domed and light that's not domed. And can't we know for sure that they've never really done the experiment where they actually tested the brightness of the slits? They all do this math saying, look how it's a perfect theory and it always comes up with the right answer. Well, the two answers will be fundamentally different if you use laser light or you used an aperture to create dome light. You're going to get 2 fucking answers regarding the distribution of the intensity of the light. And that's a fact. And the fact that they don't even do these experiments and ever test their own results is just made more obvious by this fact, where they don't even realize they're not even doing the same experiment, goddammit. I mean, doing it with a laser is not the same experiment as the Young experiment. It's not even close.
I guess. Right. So that's me done, except I will...
But again, they use exactly the same math. I mean, doesn't it just show a vacancy in the math, that the math doesn't care what the light source is? Doesn't that smell a little bit? I can have light that's much more intense at the center than it is at the fringes, and somehow it doesn't matter to the math? Come on. We know that this is a constant in the math, and that the constant, you can't change the constant and have the same results. We know that. So if you're changing one of the constants, one of the presumptive constants, obviously your math has to change. So I'm just arguing the single slit experiment with a laser beam, the central maxima is not 8 times brighter. It's a lot less than 8 times.
Quickly review. This is some ideas I had.
Quantum mysticism? Oh, please. Get some better ideas. All updates to config have... no, that's computer science. Conservation of information. Yeah, well, information's a silly idea. There's no... You can't conserve... There's no information. I'm just saying, the only information there is that, yes, we know the whole thing's deterministic, so you can run it in reverse. If you have enough information, you can run the whole thing in reverse. But there's no book you can read and say, oh, okay, here's the information's collected over here. Let's read the information book and we can see what the universe did. No, you can only run it backwards in a model. You have to model it and then run the model backwards. There's no information hidden anywhere. There's no shortcuts to the past. You have to just replay the whole game to get back to the past. You can't get there through any shortcut.
Right, yeah. There we are. So, reasonable Inmendham video?
I will say it does count as a reasonable video, reasonable response. I'm sorry that your fucking response to my paper wasn't this disciplined and careful and decent and all that kind of shit. And so whatever. Yeah, fine. If your objections to my paper were articulated in this manner, there wouldn't be a problem. But instead you decide to read it like Donald Duck. And, you know, you should have waited till I had finished the magnetism section, because frankly that one's kind of slam dunky. But whatever. So I think I've answered your questions. Piro keeps claiming that there's some he's proven me wrong on something. Would somebody demonstrate to me, please? And I will do everything I can to prove that Piro is wrong about proving anything, because he's never proven anything ever. It certainly hasn't proven I'm wrong about something. So anyway, till next video and such. Thank you. There, I'll say it. But yeah, if I play those other videos in the future, I'm not going to say thank you. But anyway, we'll leave it at this for now and to see how things go. Thank you. Oh yeah, I thought I'd point out, it snowed like fucking hell here. It's like 4 feet of snow. So anyway, I have some video of shoveling. So, but I'm not going to put in this video. I don't feel like editing. My back is going to be shit tomorrow. But it's like, there was drifts 4 feet down. There's an insane amount of snow out there. There's an insane amount of snow on my roof. I was actually pulling it off my roof. You know, I invented this. Right, so I took the frame from a broken box fan, you know, the 24-inch box fan, and I tie a rope on it, right? And so you just throw the frame up on the roof, you know, and it sinks into the snow, and then you can drag the snow off the roof, and it works really quite good. So I invented that. I have a 5-foot-high vent for the furnace, right? That sticks out of the roof. It's 5 feet high. And yeah, actually, I'm so good at horseshoes, I can't even help but get ringers even when I'm not trying. But yeah, I threw it up there, and 5 foot high. You know. So anyway, yeah, there's no way to get it off. So, but I was almost done anyway. But yeah, if I'm going to get more snow off the roof, I have to go find another fan to take apart, I guess. Because I don't want to have to get the ladder and no, it's too much. But anyway. Can't say it's the worst snow I've ever seen, but it's pretty close. At least the worst for one day. I mean, 1 day of snow, and this was just, this is just a monster amount of snow for 1 day. Anyway. I mean, I really shouldn't have to do this kind of shit anymore. First, I'm too old to be shoveling snow, but it seems like a waste of my potential. I should be doing much more interesting things with my brain than shoveling snow. Yeah. Anyway, the next time.